Next up, we are going to wrap up Chapter 7 by looking at types of reactions and how to classify reactions. We've already gone through these two types. Types that we haven't gone through yet are single displacement, synthesis reactions, which are also called combination reactions, and decomposition reactions. So again, the new ones we're going to look at today are single displacement, synthesis or combination reactions, and decomposition reactions. Now for these last three, you will only need to identify the reaction type. We are not going to be completing and balancing them. The reason why I have these asterisks here is these are the only ones that we will be completing and balancing in this course. So again, we've gone through these, and these are ones that you should complete and balance. For the rest of them, you just need to identify the reaction type. So as far as the reaction type goes, let's say we have reaction looks like this: AB plus C. And this one is going to be if C is a nonmetal. And if C is a nonmetal, what happens is that the nonmetals trade places that are in here. And when they trade places, we wind up with products of AC plus B. Now we could have another situation where when we look at it, we could have a reaction which we have AB plus C, and we can have where C is a metal. So we could say if C is a metal. And if C is a metal, it's also going to trade places, but in this case it will trade places with A. And when it trades places with A, products we wind up with are CB plus A. So these are the two different types of single displacement reactions. Synthesis reactions, these are probably the easiest ones to do. In a synthesis reaction, what happens is we have two or more reactants, and we have a single product. And in a decomposition reaction, actually we usually write it like this: A plus B makes AB. In a decomposition reaction, we have AB, which is a single reactant breaking down into two or more products. And again, these should make sense. If you decompose something, that means you start with one whole unit and we break it down. With synthesis, that means we start with multiple units and we put them together. So what I'm going to do here is I'm going to start with a reaction, a demo. And in this reaction, and we can write these down, I'm going to start with some silver nitrate. And if we wrote out a formula for silver nitrate, we need to know the charge in the silver ion. Its charge is 1 plus. Even though it's one of those elements, let's put in a periodic table here. Let's insert periodic table. Even though silver sits on the periodic table right here, and it's under the category of ones that are mostly ones that have variable charges, remember that these three elements here are ones that have fixed charges and are ones that you need to memorize on your list of ions. Nitrate is a to memorize one. Its formula is NO3 with a charge of 1 negative. So if a single positive and a single negative, what happens? Cancel out. And this is dissolved in water, so it is aqueous. Then what we're going to do is we're going to react this with some copper metal. And I always like to carry some copper metal around on my cart. So we'll just cut off a piece of copper metal here. And I'm going to go ahead and wrap this around my stylus just to get a nice loop on here. And then we're going to put it into this test tube. And once we put it in the test tube, we should see that this is a colorless solution. And then we're going to lower the copper wire into this solution. And we're going to let it do its thing. So I'll put it in, let it react for a bit. And again, you see the clear colorless solution. So now, we let this set aside and do its thing. And while it's doing its thing, I have 3 questions here for you. And again, we react it with copper solid. So the 3 questions on here start with this one. And this one has 2 answers. So select both answers. Look at it carefully. We have hydrogen reacting with oxygen to make 2 moles of H2O. Is this a synthesis reaction, decomposition, single displacement, double displacement, or combustion reaction? And there's going to be 2 answers that apply to this one. So select both answers. 5, 4, 3, 2, 1. Good. Correct choices. The synthesis was the easiest one of them. It's synthesis because? Right. How many reactants do we have? 2. And how many products? 1. So we're basically combining these into a single product. That makes it synthesis. How is it also combustion?
Because it's hydrogen reacting with oxygen.
And where have we seen that in here?
Combustion.
Right, the balloon, the big boom. When we ignited the hydrogen, we were reacting the hydrogen with oxygen. So that's when we burn in the presence of oxygen, that is combustion. Next one. Whoops, did we skip one? Oh, here it is. We have H2O2, aqueous. And this is the one we did at the end of class. Must have been a week ago today. We put in the manganese dioxide or the manganese 4 oxide catalyst. Let's get our answers locked in. We'll give you about 10 seconds. These are ones that you should be able to identify on site. We'll count down. 5, 4, 3, 2, 1. Very good. This is a decomposition reaction. How many reactants? 1 and 2 products. Makes it a decomposition. Next up, we're looking at this one. Now, I've shown the equation, and let's actually look at what's happened to this one. If we look at what's happened to it now, notice that the color is now blue. Okay, in fact, the wire looks a little fuzzy on here. What I'm going to do now is I'm going to pass it around. We'll start it here. We'll send it to the back. Please don't shake the shake the wire. And don't shake the test tube so everybody gets to see these nice, beautiful crystals that are growing on the wire. And if we want to look at what happens in this particular reaction, let's first of all come back to here. And the copper now is going to trade places with something. What do you think it's going to trade places with?
Silver.
The silver, exactly. And so basically these two wind up trading places. Once they trade places, then we're going to wind up with copper nitrate and silver. And those fancy looking crystals on there is silver metal. That's an easy part. The other stuff though is copper nitrate. And if you remember where copper is located on the periodic table, if it's located here, that means it has a variable charge. And so what we don't know is what is the charge on that copper. Now obviously if you're looking at the Socrative app, you've already figured out that I've determined it here, but there's a way that I can determine what that is. And the way we determine it is by looking at the color. Turns out that the transition elements are colorful compounds. When they combine with other elements, they typically form colored compounds, and the color depends on what their charge is. Now, have any of you ever been to the Statue of Liberty or seen pictures of it? What color is the Statue of Liberty?
Green.
Green. Now, anybody know what the Statue of Liberty is made out of?
Copper.
Copper, exactly. Now, copper actually has two different types of charges. It has a 1+ charge, or it could have a 2+ charge. When it has a 1+ charge, it tends to be kind of yellowish or brownish. And if it's a 2+ charge, it's either kind of green or blue. So I look at that one and I see which color. Blue. That would tell us that I'm looking at copper 2. And if that was yellow or brown, then I know I was looking at copper 1. So again, you don't have that experience, but again, chemists have studied this, and we know by looking at the colors very often which one is in there. So this one here, and that's why we're not completing and balancing these equations, because you don't have the ability to predict with your background what those charges are going to be. But we can take it and identify it as a given reaction type. So if it's copper 2 nitrate, that means we have copper with a charge of 2+. Nitrate is NO3 with a charge of 1 negative. So our formula here is going to be Cu, NO3 in parentheses, and a 2. The phase label is going to be aqueous, as we see there. We can also look it up in our solubility table. And then we go ahead and balance it. How many nitrates are in this formula? 1. And over here we have 2. So to balance the nitrates, we'd put a 2 in front of the silver nitrate. That changed the silver. So we have 2 here. So on the other side, we need to put in a 2 in front of the Ag. And of course, we have 1 copper on each side. And this is balanced. So on your Socrative app, what type of reaction is this? Is it a single, what is it? Synthesis, decomposition, single displacement, double displacement, or combustion? Get your answers locked in. Go 5, 4, 3, 2, 1. And this here is a single displacement. Now for those that put double displacements look very similar, except in a double displacement we start with 2 ionic compounds. Okay, so it kind of looks like this. And then we're trading places with the positive ions. They're still trading places, but we have 2 ionic compounds, whereas in a single displacement we have a single element that's being reacted. So that takes care of chapter 7. Are there any questions other than the one you had, which is beyond the scope of what we would do at this level? Okay, so now what I'd like to do here is I'd like to take this back and show you what happens. We can now take this wire, and now those that didn't see it at the beginning, notice what's happened, that we've got even more silver on it. And so what I can do now is I can take this piece of wire and I can shake it off. Of course, we still have our copper metal, and the stuff that's precipitated at the bottom here is silver metal. And the blue stuff that's in solution is copper nitrate, specifically copper 2 nitrate. And we know it's copper 2 because it is blue. If it's copper 1, it would be brown or yellow. And of course, you don't need to know that because you need a lot of experience working with those to know which colors to expect. But that's one of the fun things about chemistry, is you can look at those oxidation states, look at those charges, and see those different colors. And there's a whole sets of theories as to why we see colors. We don't even have time to go into that in this class, mainly because of the theory is pretty deep behind it. So we stick with the fun stuff. Most of you wouldn't consider that the fun stuff, that deep side of the theory. Okay, any questions?